Question 5a and b says a boy standing at the point M on the same horizontal level as the foot T of a vertical building. He observes an object on the top P of the building at an angle of elevation of 66 degrees. He moves directly backwards to a new point C and observes the same object at an angle of 53 degrees. If MT equals 50 meters, illustrate the information in a diagram. B1, calculate and correct to one decimal place the height of the building. Calculate and correct to one decimal place line MC. So let's illustrate the information. A boy stands at the point M on the same horizontal level as the foot T of a vertical building. So let's say this is the vertical building. The boy stands at point M. The foot of the building is T. On the same horizontal line, the boy stands at point M. He observes an object on the top P of the building at an angle of elevation of 66 degrees. So from here, this is the top of the building. He observes an object and our angle is 66 degrees as our angle of elevation at the top P. He then moves directly backwards to a new point C. He moves backwards. This is the position of the boy. So if the boy moves backwards, that's away from the building, moves this way. So we'll draw another line to a new point C. He moves directly backwards to a new point C and observes the same object at an angle of 53 degrees. So the same object, the angle of elevation now is 53 degrees. So the new point is point C. And the last part of the question says if MT is 50, so MT or TM is 50, the distance between this is 50 meters. Illustrate the information in a diagram. That means we've illustrated the information as first part. Calculate and correct to one decimal place the height of the building. This is the building, this is the height of the building. So let's name the height of the building X. To find the height of the building, this should be known as the right angle triangle. And we can use Pythagoras theorem to solve this first, putting into consideration the first triangle. We have the angle at 66 degrees, and this line we're looking for is the opposite. So we are looking for the opposite, and the hypotenuse is always facing the 90, which we don't have. And we have our adjacent as 50 meters, so this is our adjacent. So we'll solve using Pythagoras theorem. The best that fits is tan theta that has opposite and adjacent together. So we say tan theta equals opposite of adjacent. So tan theta is 66 degrees equals x over 50 meters. Our x is the opposite, which is unknown, which is also the height of the building, and our adjacent is 50 meters. So we'll solve. We cross multiply. Can say tan theta over 1 cross multiply. X times 1 is x equals 50 times tan 66. So we have 50 tan 66, which is x equals 50 times tan 66 is 2.2460, which is, when you multiply 50 times 2.2460, it gives you 112.3 meters as our final answer for the first one, the height of the building. Therefore, the height of the building is 112.3 meters to one decimal place. But B2 says, calculate and correct to one decimal place line MC. This is line MC. This is line MC. Let's call line MCA. So we'll now solve. Note that this is another triangle. PMC is another triangle. And finding A or finding MC, find it using not just a way. You can find it in several ways, but the best way to find it is to consider this big triangle, ignoring this inner line. Then it's also a right angle triangle, and we can use it to find 50 plus a together. That's the total distance here. Then from that, subtract 50 from the answer and get what a represents. Or we can use this 66. Since this is a straight line, with this 66 we can find this angle. That's 66 minus 180 will give you this angle. When we find that and we have this, you can get the angle for this. That's the sum of angles in the triangle. We can then use this 50 and this to find this side. Then we find MC using sine rule. But there's a shortcut to it. The shortcut is imagining this line is not there, the line of elevation that forms 66 degrees. We use it to find our A. So let's redraw to show what we mean. We have this while ignoring the 66 degrees angle of elevation. We have 53 degrees, which is made of 50 plus A. We have our 112.3 meters here. And this is our right angle triangle. Now we're looking for this. We can apply, this is also opposite over adjacent. That's, we have our opposite and we're looking for our adjacent, which says tan theta is the best fit in our SOHCAHTOA. To do this question, opposite over adjacent. So we have tan, our theta is 53 degrees equals 112.3 over 50 plus A. The total length here is 50 plus A. You're looking at this, so this is 50 plus A. We can say tan 53 over 1. Then we'll cross multiply. We have 50 plus A in bracket times tan 53 equals 112.3. We can find tan 53 and not open the bracket. So you have 50 plus A times tan 53 is 1.3270 equals 112.3. Since we are looking for A and want to get rid of this 1.3270, we divide both sides by 1.3270. Rather than open the bracket and complicate it with our A being complex, we can just get rid of this. So divide both sides by it. This cancels this. We have 50 plus A equals 112.3 divided by 1.3270, which is 84.6. Our A, we take out our 50, take out this 50. A equals 84.6 minus 50. Because here you have a plus 50, goes out equal to sign and turns to minus 50. A is 34.6 meters. Therefore, line MC is 34.6 meters, which is here, that's the distance between M and C is 34.6 meters, which is our final answer.